I'll quickly review whatever we have learned till now. We started with what we wanted to do was getting started with R. We just want to be comfortable in R, some of the basic commands in R, where to write the code in R, how to debug the code, how to find out the errors, etc. So what did we do? We started with R introduction, what exactly is R, what are the capabilities of R, and then we went on to the installation of R. You have already installed the tool R and R Studio. Then we saw the main windows within our environment, where to code, what is console, what is workspace, what is the output window, where are the packages, where is history, etc. Then in console we tried few quick codes and their output. Then we saw what are the objects within the workspace, where is the workspace. We saw the output, some of the output, most of the output is within console. And then we discussed about the assign operator, one of the most important basic feature or basic command within R that everyone should be working with. Then some of the naming conventions, and then we went on working with R. We tried few codes and we tried to see whether what are the errors and where are the errors. Then we discussed about packages, how R is actually arranging this whole code into packages and how to install a package, how to check whether the package is attached or not, and installing a package, using a new package, how do we use that new package to fulfill the particular job that we were not able to do without that package. And then we discussed about some of the useful packages in R. Then we went a little deep into basics. What are basic data types within R? We discussed about vectors, we discussed about data frames, we discussed about within vectors, we discussed about how do we access the vectors, how do we operate the vectors, how do we change the vector elements, etc. What are types of vectors. Then we went on to the data frames, how do we access the data frames, different ways of accessing the data frames. And then some of the built-in data frames are nothing but the example data sets that are available within R. Then we discussed about the list. That is, a list is a hybrid data type that can have anything inside it. An element of the list can be anything. So we saw some of the examples of the list. Okay. And then we discussed about other types, data types, that is factors. A factor is a categorical variable. It's a kind of a character only, but in a formatted in a particular way so that some of the calculations made easy. A matrix is nothing but multi-dimensional array. Then we discussed about the factor, making a factor out of a string. And then we discussed about history, where is our history, and then how to write the R script, where is the script, from history how do we push it to the script, from script how do we execute the commands within the scripts, partial commands and full commands, etc. Then saving the R script, it is just save as, and we can save the workspace image as well. Like this one we will do it slightly later, because once we do all the operations we can actually save the whole image. I'm not talking about just the code that we wrote. We can save the whole image as a project itself, so that next time when I log in and load the workspace, everything as it is will be populated. Let us suppose if you have created 3 data sets, 4 object variables, and so on, and then you wrote some code also. In the history also there are some commands. If you save the workspace and next time when you load the workspace, everything will be starting from there. So that is called saving and loading the workspace. We will retry this once again slightly later. So to recap all our commands and whatever we learned till now, I would like to start with a lab exercise right now. So this is our first R program, full-fledged way we'll try to write. Okay. Create an income data vector for 4 employees with the values 550067. So this is what you need to do first of all. Create an income data vector. How do you create that? Try each and every one of you. I'll just do it but with a lag, but you can go ahead and do it. You have to create an income data vector. I hope you have saved your code last time. If you haven't saved, then you wait until I write the code. Create an income data vector for 4 employees with values 5500. So how do you create a vector using C operator, right? The name of the vector is income. So income C of 5500. You need to create a vector like this. Everybody can hear me, right? Can you please confirm? Okay. So this is how I created an income data vector. Income, if I print it, I can see that. Create a new variable called tax. Save 0.2 in it. Create a new variable called tax. Save 0.2 in it. That's how we do it. Create a new variable called year. Save 2015 in it. Now go ahead, do it, all of this. Quickly. Create a new variable year. Save 2015 in it. Create a new variable called company. Stat info in it. Derive net income by deducting tax from the income. So net underscore income, I need to deduct the tax from the income. So income minus tax into income. So tax is 20%. I have to reduce 20% from the income, or else I can directly write income into 1 minus tax. So what is net underscore income? This is the amount. Actual income is this. We reduce tax from it. Create an employee name vector with 4 values. Since these are strings, this should be the answer. Whatever command you give, this should be the answer that you should be getting. Or the technically right way is this one. This is the answer that you should get. Then name vector with 4 employee values, C operator. Red is the first one. Why am I giving quotes here? Because these are strings. This is the name vector. Create a data frame with employee name and net income. So what should be the data frame name? So I will give employee. I'll give the name of the data frame as employee data dot frame name, comma, net income. Data frame created, employee. You can see the data frame here. Yes. Create a new list with all the above information on company, year, tax, employee name, salary, and salary data set. Create a new list with all the above information. How do we create a list? Let's call this new list as employee EMP list, and I need to write list of information on company, that is company name. We saved it in company. Everything we need to include: year, tax, employee name, employee salary. Is this a list that is created? Can we see that? What is the structure of this? This is a list of 5 elements. Is it clear, everyone? Any questions on this one? The way, can you recollect all these commands that we have been using? This is the question, lab question. This is the answer. Once you are done with this lab, please let me know. I will go ahead with the next slide. Everyone, whomsoever finished this lab, please mention it in the chat window that you're done with the lab. Okay, okay, okay. We'll move on then. So this is our first R program. We're done with it. Okay. Now R functions. R functions are nothing new. They are very easy to handle like any other function. What is a function? A function will have the function name and the type of parameters that we need to give it to the function. Okay. Imagine this function, round off function. What are the parameters that function might expect? We need to give the number that it need to be rounded off and how many digits, or a function name is absolute. What is ABS? It will give the absolute value of a particular value that you have entered, square root. So simply we just need to use the function, and we need to take care of the parameters that need to be passed on. If we wrongly pass the parameters, we'll get an error. Let us suppose absolute value of x, and we give the x as a string instead of numeric value, then definitely it will give an error. If it is a string function, we need to pass on the string variable. So all that you need to know is what is the function name, what are the values that we need to give in as input or input parameters. Let's do a quick warm up. So just try this very quickly. Try this as it is. You just enter first one. I'm finding the absolute value of 20. I'm saving it in y. Second one, I'm finding the sum of y plus 5, saving it in x. Third one, fourth one. Quickly do all this. Try to understand in each of the steps what am I doing. Here I'm finding the substring to upper, converting everything to upper. So go ahead and do this quickly. Once you are done, just put it in the chat window that done. Once you are done, please inform me. So what is the final function doing here? grep. It's a string function. What it does is it will search for the particular string in a given bigger set of strings or a big sentence. Let us suppose in customer ID, whereas customer ID is a bigger string, grep will search for the particular character and wherever it is coming. grep searches for the, if you are not aware of what function is doing, you can actually find out in the help. So if you don't know what a particular function is doing, you can say, let's say if I don't know what grep is doing, I can do this. Then I will see the full documentation, pattern matching and replacement, what grep does and what are some of the examples of grep. The best part is finally they will give us some examples. So sometimes if we don't know how to use a function, we can simply try out these examples to understand it in a better way. So it's a pattern matching or string searching function. So let me quickly run all these. So first y, what is the value of y? that is absolute value, then X, then Z, rounding of the Z, then cust ID. What is cust ID value? Mismatch. Then I converted it to uppercase. GREP 4 is found, that's why it's there. If I do the same GREP, try to understand what is GREP doing. If I do the same GREP, that is pattern matching, if I give something which is not there inside this string, so this D is a string, so let me give it this way. Is it there inside that one? Nope, it's not there. Is it there? Then it might ask D not found because there is nothing called D object. So we have to, if I'm searching D in customer ID, there is nothing like D. Nope. But if I give T, that is there. So when it is there, it will give us the output as 1. If it is not there, then it will not give. Is that clear? Shall we move on to the next slide? Cool. Now this is a very important topic that we need to discuss and remember. What are some of the most common errors that we commit while working with R? The first one that I have observed uh, during my whole experience in R is the syntax error. You will be defining the data set as something, and you will be very comfortably writing you will be ignoring the cases and wondering, looking, and you will write the code and R will throw an error saying that the data set not found. Okay. Now we will be wondering, anyway this data set is created, there is some problem, but the problem is you haven't taken care of the cases. You might have defined like this and you trying to print this, or somewhere else you are referring this, and the error will come, error myvar object not found. This might look very obvious here when the data set is large, when there is a lot of lines of code, then you might actually maybe making this type of error. So whenever you get an error, do not think your whole program is wrong. You might be making a simple mistake as this case sensitive language are. So we need to be careful with that. Could not find the specific function. Let's say we are going to write the code. Within the code we might be using a function that is not available. What do we mean by that? We see that gplot or any other function that we are using that is already available and was already used by someone. But when we are using it, it says could not find the function. What does that mean? That means the package that is containing that particular function not installed on our system. We need to make sure that package is installed as well as attached. Then only we can use that function. Otherwise, simply directly writing the function might lead you to this error. You have to make sure all the relevant packages are installed and attached before running the code. Then only the functions or all the functions that you are using inside the code might work. That is second most common error. Second most common error is when you forget to, or when you don't install the relevant library, you might not be able to use all the functions. Non-numeric argument operator, binary type. So this is another most common error. Let us suppose you are doing something that is not meant for that particular type of data. Let's say if this is name, if you see this vector, this is a string type vector. If you do any arithmetic on it, then you will get this type of vector, this type of error, non-numeric. So you have to make sure that whatever we are doing is kind of meaningful operator, then only we will get the results. Otherwise we might get binary operator or invalid type argument. no such file or directory. Sometimes we write the file name wrongly or give the path name wrongly, and will be wondering very confidently, thinking that something else was wrong. Sometimes simply not writing the file name correctly, not mentioning the path correctly might give us this error. No such file or directory exists. R help, so we can use question mark and the function name. It will give huge documentation that is available for each function, or else you can directly go and search in Google, and anyway it will lead to the R help page. So in this particular discussion or the session, what we learned is some of the basics of R. This is kind of ABCDs of R. This is like simple start to what we are going to do, a lot of complicated operations later on. But these simple basics need to be very much clear. So that's why we spent a good amount of time on that. So that if you are comfortable on these basics, then only you will be able to understand the type of errors. You will not be making simple or silly mistakes later on. So we will be using all these topics and the knowledge gained from this session very often later on. So, and the next section will be on data handling techniques. How do we import the data? How do we create the new data set? How do we manipulate the data? How do we merge and join the data sets? Because this whole training is about data science and data analytics. So the data importing and data manipulations it plays a very important role. Now I'll pause here. As I discussed with you, I'm going to show you how to save the whole workspace image. So let's get back to saving the workspace. So we can go to session and save workspace as. So we can save the whole workspace. It is not like saving the simple R code. It will save the whole workspace image. What do I mean by workspace image? It will save all these objects. Employee will be there, L will be there, student. Next time when I go back and load this workspace, everything that is there here, everything that I can see, everything will come as it is. In fact, after 2-3 days or after a week, if I load the same workspace, I will be exactly coming at this point. Okay, it will appear exactly like this. That is the uh, that is how you save the workspace. Earlier we were talking about saving the code, that will just save the commands in a simple text file, but this one, it will save the whole workspace. You can try out save the workspace and load workspace. Just remember that not every time you might need all the elements or objects that you have created during the session, but if you require them, you can save the workspace. Now, if you have any questions, then we can take them. Otherwise, we will move on to the next topic. If you have no questions, just say no in the chat window. I'll go ahead to the next topic. Data handling in R. This is our next topic of discussion. So as we already discussed in the first class, that data handling is the most important skill. I mean, you don't see data analysts directly jumping onto the analysis without actually importing, curating, validating the data. There are so many steps before actually doing the analysis. Sometimes we may have to create the new variable. Sometimes we may have to merge some data sets. Most of the times the data set comes from different data sources. We might have to merge them and create or prepare the data for analysis. Sometimes a data set is, some part of the data set is on SQL server, some portion is in SAP, or some other portion is in some other database. We might have to gather all the data. So it's very important to have a very good understanding of data handling techniques. So in this particular session, we are going to discuss about data importing. It's not imploring. Data importing from files, data importing, database server connection, working with data sets, manipulating the data sets, creating new variables, sorting, exporting the data sets out of our data merging, and all the commands that are related to data handling within R. So let's start with data importing. There is a simple good news here. Data importing within R Studio can be done very easily because there is a direct shortcut for importing the data. I'm just cleaning out my whole environment. The way I do it is, there is a small broomstick here, right? We can use that. So I just cleaned everything. Now I'll import a data set directly. You just need to click on this and select the data. Let us say I want to import this superstores data sample CSV. I'll just click on this from the local file. I'll go and locate my data set. Where is it? Superstores data. That is sample. Superstore sample CSV. So I located the data set. Now R is saying whether there is heading in the data set or not. I would say if there is no heading, R is giving for creating the data frame as V1, V2, V3, V4, right? Whereas if I say heading is there, it is taking the first row as heading. So you must be knowing whether the heading is there or not, or you can see it here. Everything is taken as automatic. We don't need to worry about them. Maximum you can change the name of the final file that will appear in R. I would say simple sales data. Then the data frame name will be sales data. I would say import. Actually, this code is written by R. When I said import data set, inside R this code is written, and this code view sales data generates this view, sample view. Instead of printing here, a sample view is created here, and this one actually fetches the data set. This is the code. So if I again remove this data set, okay, now there is no data set. Either I can import the data set or I can write this code. What is the code? Read.csv. Now you might have observed that read.csv is a function. You name the function, you give where exactly the data set is. Depending on that, you can import the data, and the final imported data set name should be kept here. So here I don't want to give sales underscore data. I simply want to name it as sales. And this is the path of the file where my data set is. It need to be really accurate, then only the data set will be imported. Read.csv. Sales, it is imported. What if the path is wrong? If I am giving something like training 1, it will say no such directory file exists because I gave the path wrongly. You need to give the right path name. So dataset is created. Similarly, you can get the same, do the same kind of thing for other datasets. One point that I want to highlight here, if you see here, this these slashes are forward slashes, whereas if you copy paste from Windows, the slashes will be backward slashes. What I'm trying to say is, if you are copy pasting, let's say you know where the file is. So window is like this, Windows, but R won't work that way. If you want to make it work, you need to give two slashes, two backslashes, or else a single forward slash that we had seen earlier. Anyway, we will directly work and see how it really impacts. So this is the code. Read.csv is the function for importing the dataset. Let us do a quick lab. So I have shared the dataset links with you guys. On Google Drive, I have saved the datasets. I have given you access. So only download the datasets that are required for now. So for now, you can download sample sales.csv. So you create one folder for this training program. Within that folder, you create some files for the videos that you are going to get, create some folder for datasets, create a folder for PPTs. At least right now, create a folder for datasets. In that datasets folder, you download these files, sales underscore sample file. Download this sales underscore sample dot CSV, import it. Once you're done with this whole exercise, please go ahead and say that in the chat window, then I'll get to know whether you have finished or not. One link I have shared. Let me share it once again. Did anyone got the link? Google Drive datasets link I have shared. From there you can download the datasets. Yeah, so that is the link. Just before the meeting I shared it. Once you're done with it, then let me know. First one is backslash, double backslash. If you use as it is, obviously you're going to change the name of the path and all that. If you use only single slash, you will get an error in the second command. The third command is again corrected second, the other way of importing the data. Once you are done with it, please mention it in the chat window. Read.csv is the function. You just mention the file, where the file is. That's it. Done. Okay. There shouldn't be any error because the way that I downloaded the file, make sure if you are importing using this import, file import from our import dataset if you are using, and within that datasets, sales, supermarket sale. If you are importing this one, and if you are saying no, there is no column name in the file, then that is wrong. You have to say yes. Remaining everything, keep it as it is, then hit on import. This should be the output. Okay. This is not really tough. I mean, if we do it 2-3 times with 2-3 different files, we will be able to catch up quickly. The next one, importing a different type of file. Most of the times we might have to work with not just CSV file, many other type of files. SAS is another type of format SAS data files have. They have an extension SAS7BDAT. SAS files, they like the way CSV file has CSV, I mean our sales.csv format, SAS files have SAS7BDAT format. So we have a data set called GNP data, which is in SAS datasets folder. You need to import it inside R. So you need to use a function called read.sas7bdat. Okay, but that function is not readily available. You need to install sas7bdat package. Just installing is not sufficient. You need to attach it using library statement. So do all those steps. I'll show it to you one last time. Installing the package. importing from SAS file. So I need a package called SAS7bdat. So first I need to go to packages, install SAS7bdat. That is the package name. Install it. Installing the package. Just installed it. Then I have to attach the package. Library SAS7bdat. Attached. Now I can import the data. What is the dataset name? SAS datasets GNP data. First, it's better to locate the data and then get the path. So the function name is read.sas7bdat. So GNP underscore data, that is my dataset name inside R. Read.sas7bdat is the function. I just need to give the path. What is the path? Full complete path of the dataset. The dataset is here and dataset is inside SAS datasets library, SAS datasets, GNP data. So this is the path, and finally GNP, no spaces at all, without any spaces give this. Okay, now if I run this as it is, it won't run because either I have to give forward slash or double backward slash because it is Linux based. So we have to give double backward. This will work. This will create GNP data. You can see the GNP data. You can print it as well. Got it? So GNP data inside SAS datasets folder. Try to do this, everyone. Once you're done with it, then please mention it in the chat. Done with it, please mention it. Those who have finished this, import the other SAS file as well. There is one more SAS file. The name of that file is, what is the name of that file? There was one more SAS file as well. Demographics SAS7bdat. Import demographics as well. First of all, import GNP SAS7bdat. Install the library. And then import demographics. So the next one is importing the data from Excel files. Unfortunately, for importing the data from Excel file, to in R is not very straightforward. I have tried so many libraries, but none of them are working perfectly. So you can try some of the libraries like Excel SX, Excel Connect, but somehow they all of them are throwing some errors because the Excel file that you see is not just the Excel data that we have inside it. If it is a CSV file, it just has CSV data, whereas Excel files has so many things inside it. It has a lot of indexes, it might have macros, etc. But Excel file, sometimes it throws Java error, sometimes it throws some other type of error. But these are some of the libraries that you can experiment and try to import the files. So Excel files still not, it does, R doesn't have any compatible package yet for importing the Excel file specifically. These were working on some of the machines, these libraries are not working. You can try them after the class, these two libraries, or you can actually do some research experimentation and tell the rest of the class what are the packages, what are the functions that are good in importing Excel files inside R. So importing the CSV files, SAS files, we are done with it. Connecting to a database server. This is for your information. I'm keeping it. So we have actually tried it and it worked. You can use RODBC, and if you have actually a database server access, like if you have ID and password, you can use ODBC connect, and then you can give ID, password. Then generally database will have a lot of tables inside that. You have to mention the table. You can even pass on an SQL query and get the output. This is for those who already worked with databases. You can even try connecting to a database, get a particular table inside R. Now that is importing the data set inside R. Okay, once we import the data, we might have to do a lot of other operations, or later on is the real analysis, or not even the analysis, the basic exploration that starts. First of all, as soon as you import the data, these are some of the basic checks that you need to run. First one, is the data imported correctly or not? Is the data imported in the right format? Did you take care of all the options while importing the data? One of the errors that we were making was if we don't select the first row as column names, then the column names are automatically given as V1, V2, V3, etc. That is an error. Let us suppose a data set, you are expecting it to have 10,000 rows, and after importing only 5,000 or 6,000 are there. How do you get to know that? You won't, I mean, if the data set size is really large, you won't be able to browse through the data set one by one and be able to find it out. Just printing the data is not always a good option. If the data set is size is really large, even if you print it, some of the things, some of the minute details, you might not be able to observe. So it's a very good practice to check the number of rows, number of columns, having a quick look at some of the basic metadata elements, or having a quick look at the some of the basic details of the data is a good idea. What are the some of the basic details that we need to remember as a good data analyst? This is the difference between somebody who's just new to R and someone who's using R effectively or smartly. So I would say this is a checklist. Right after importing, this is what you should do. First, you should write something called dim. That is like dimensions of the data set. So let's try one by one. So you have the data set with you. You might have imported the sales data, or you might have imported the GNP data. So the first command that you should write right after importing is dim. So what data set that I have? I have already sales data. So I'll say sales, dim of sales. What does it give? It gives the dimension. What is the dimension? Number of rows, number of columns. That is the first command. Go ahead, write it. Dim is your first command. Everyone is with me, right? Next one, names. Names is the second command. Third one, head. You understood what is names, right? I did not explain it. Names is simply the names of the columns. Why are we doing this? Let us suppose we are expecting the column names as these. Let's say we have some prior information. Okay, sales data contains these column names. And suddenly we see the column names as V1, V2, V3. Or instead of importing the sales data, we imported the customer data which has cust ID and then customer address, customer last purchase date, etc. Instead of having the sales details, if it has customer details, we can just simply stop the analysis there. Then head of sales. Try to guess what head of sales is doing. What is head of sales doing? First few observations in the data. So it by default gives first 6 observations. So no matter how many observations are there, what is head? That is like first few observations, head, initial few. You can actually set the number of rows that you want to see in head. So you can see the documentation of head. In that you will get to know how many rows you want to see. You can mention that. There is an option for that also. If you don't mention anything, it is giving you 6 rows. It's good enough to get. Why are we printing first few rows? By looking at some of the data, first few rows of the data, we can get a feel of the data. Is the data coming correctly or not? Customer names, instead of customer names, customer IDs are populated there. Then we can alert the right team. We can just have a quick look at the data. Why are we doing all this? This is a checklist that will help us even before getting on to the analysis. We need to make sure the data set is imported correctly or not. This will be very helpful if you are importing huge data set where it is very hard to actually open the data and see, browse through all the details. So without actually opening the data, without really looking at the data set, we want to get an idea on the data. Head gives us first few observations. Tail gives us last few observations. Head, initial set of observations, first few observations. Tail, last few observations. Structure of the data, STR of the data set. It will give you for each variable, variable by variable, we will get the structure. First variable, what is the structure of the variable, details, whether it is a factor, whether it is a numeric, non-numeric, if it is a factor, what levels, etc. So this will give us what is the type of the variable. So if we are expecting something like customer name, or let's say product sold, or if we are expecting something units, number of units that are sold, it has to be a numerical value. Instead of that, it comes as a string or character, then there is something wrong. Income should be numeric. Instead of numeric, it came up as a string. There are some values that are non-numeric. Then we can alert, or we can find out why, what is the problem. We can take a note of all those issues right at the beginning. That is the structure of the data. In fact, we can even do structure by each variable by variable. Instead of the whole data set, if you want to particularly go for one variable, you can do that. Or if you really want to see the whole data set, I don't suggest this personally, but if you want to see, if you know that data set is small, then you can use view command, you will get the snapshot view. Or anyway, we have the print command or directly print the data. Printing the data is not a right option. Remaining all are the checklist. So this checklist will help us to get a quick idea on the data and the type of import, whether it is correct or wrong. These should be on our fingertips while we are working with R. As soon as we import the data, these should come automatically. As soon as you import the data, at least you should write dim. Okay, what are the dimensions, what are the number of rows and number of columns. And we should recheck whether number of rows are as per expectation, number of columns are as per expectation. Quick summary. So the earlier one is a quick checklist. Again, we can get the summaries of the variables if we want to really dig even more deeper. I mean, we want to be 100% sure that the data set is correct and nothing has gone wrong. Then we can do the structure. Then we can use something called a summary function. We can get a quick summary. If we know about this data, let's say if you are working in this business day in, day out, then you know each and every variable, how it behaves, what are the upper limit, lower limits of each variable. Generally, it happens in business. So if you are talking about sales, if you are working on that sales for a long duration, then you will be able to identify the issues just by looking at the summary. Okay, you will tell that, okay, units sold can't be this much lesser, or it can never reach 205. Let's say if this is age variable, okay, age can never be 205, something like that we can find out by looking at the summary. We can even find the summary of a particular variable. That is nothing new, it is just a particular portion of the output that we have just seen above. If the variables are categorical, then the summary might not make sense. You see here, where's summary? Yep. If the variables are categorical, here this summary is not making sense, then we can create the table, frequency table. So this is online, how many are online or retail sales channel. So we can create the frequency tables. If the summary is not making sense, then you can create the frequency table just to get a quick idea on some of the variables. Here is an important command again. This is isNA. Tell me what isNA doing here. Just spend some time, understand what is this. Tell me what is this. Anybody got what we are trying to do here? If I would have given directly is NA sales, it says false, 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 everything false. Then I found sum of all these NAs. Anybody got it? Tell me what is this. That's correct. It is used to find the missing values. Is NA, if there is some missing value, it will be true. If I add up all, if I just find some, false means 0, 0, 0, 0, right? Sum of all this. Let's say if there were 10 missing values within the whole data set, then it will be 10. Since there are no missing values in our data set, that's why is NA 0. You can even do it for a particular variable. We know how to access a particular variable. First I'll do it is.na. Is.na is the function, and you pass the parameter either data set or a particular variable. What is the variable name? Are there any missing values in units sold? False, false, false. If the data set size is large, we can't check all these falses. So we can directly find the sum of is and a, how many such what are the trues and what are the false in this NA. Units sold 0. Got it, everyone? Shall we move to the next slide? Yes. Now this is the lab. Right at the end of this class, we are going to do this lab and finish. So I'm going to maximize this screen. I'm not going to share the code. You try it and then let me know. Not all commands, not all questions can be answered by the commands that we used till now. You might have to Google some of the answers. Okay, I did not share all the code with you. There can be something that you might have to find it out on the go. Okay, try to import it, try to do it carefully. Meanwhile, if you have any questions, you can post them on the chat window.